Good morning to everyone. Now, let us start epistemology of engineering design. So, how do we consider design as an activity? So, design as an activity is related to pre-execution stages of making new products. So, design as activity is organized as art versus technique, or it is form versus technique. Fine art, industrial design, architecture, and engineering are typical examples of design as activity. Next, we will see design as planning. So design as planning is related to systematic mental process prior to action and conceptualization, the thinking part, which is pre-execution stages for planning, composing, and decision making. While design as activity is related to professional endeavors like art or engineering, design as planning is more affiliated with management of a wide range of fields from business to military, from hospitals to academy. Now, what is design as epistemology? It is related to synthetic methodologies needed for mental apprehension of appropriateness for change. Design epistemology is distinct from analytical methodology, which is crucial to develop scientific initiatives. So, epistemology of engineering in the light of four key questions of philosophy of knowledge, that is ontological, epistemological, methodological, axiological questions. For the case of engineering, the ontological question inquires or it questions about what reality can engineering know. Ontology means what reality deals with reality. Epistemological question looks into what is engineering knowledge, reality knowledge. Methodological asks how can engineering knowledge be built, steps to build engineering knowledge. And axiological questions, that is ethical questions. It is about value of engineering. So what is engineering? What is knowledge? How is it built? And what is the value? Value means ethical sense. Value in ethical sense. This is how we define epistemology. So rigor, creativity and change in engineering. The recent time we are finding all these in engineering. Let us see that. So engineers' drive for innovation can be curtailed by bottom line finances available. So obtaining parts for experimentation in practically zero time can require very resourceful effort because rigid systems in place for parts procurement too often have been established primarily for production and just-in-time receipt. So one of the solution is obtaining samples, but that are sometimes unreliable parts, and a single failure can result in quick dismissal of the project. So rigorous design rules such as parts derating design review are important, but with tight constraints and finances, they affect the time limit for experimentation. So what are the suggestions that are provided for engineering design? Make a list of solutions early in the design process. That would be the solution proposed, but we can have a few more solutions. List of solutions means we can have solutions that are economic, that are innovative, that might save cost, save time. One solution to save time, another solution to save cost, and another solution that is very innovative. So most design efforts involve team effort and ability to compromise combined with the resolve to do the right. So sometimes you can get your wishes met by just floating an idea and letting others scramble to take credit for it. So keep the design much simpler and anticipate how the design will look when it is made into a product. Will it survive the test of time going forward with minimal engineering change orders and compromises? Will it fill a requirement that could be adapted to some future upgrade with minimal interface changes? Can we fill this space with something better in future? After that, you need to discuss your idea with others in various disciplines. You have to do brainstorming and get ideas from others. For example, management, QA, reliability, manufacturing. Make the first meeting with customer exciting by showing the customer as the end user is the one who is going to pay for your product. So you have to make it interesting, and you must show them how the product will actually look like mock-ups, and make sure the customer understand. That's why we said an engineering must possess a very good communication skill, so that whatever we are writing as a research, as an academic or industrial research, should be communicated properly to the end user, so that he or she will show some interest in buying. Okay, so be practical. Where can the parts be obtained, and try to ensure the sample parts are reasonably reliable and not counterfeit. And finally, remember, this is very important. You have to consider this in your mind, that remember, not all projects will be overwhelmingly successful. So see here, not all projects will be overwhelmingly successful. Some are praiseworthy but flawed concepts, while others may be inadequately funded. Praiseworthy but concepts are flawed. We cannot bring it to practice. While you cannot be responsible for everything that happens, never ever let distractions interfere with your next good idea. So as I have already told you, perseverance is the key. As they say, the only thing that does not change is change. So you should be ready to change, because change is never going to change.